Hi there, it's Matt here, and a very warm welcome back to this podcast. Often on this podcast, I speak about sleep for the brain and all the remarkable brain benefits that sleep supports. And sleep very much is for the brain. We've discussed the slow oscillations of the cortex, the neuronal firing that consolidates memories, the emotional processing performed by the limbic system. It's therefore a natural assumption. Sleep is a brain state, so the brain must be running the show. That is, sleep is not only for the brain, but conversely, it is the brain that controls sleep and the different types of sleep and how much you get. I mean, what else could be controlling how much you sleep other than your brain? Well, today I'm going to reveal some fascinating new findings that have made us realize a striking truth. There's another added control center of sleep, and it sits within your gut. It turns out that trillions of microorganisms living in your digestive tract, bacteria, fungi, viruses, hold a certain amount of power over whether you sleep well or spend another night staring at the ceiling. This is the story of how we discovered that the answer to better sleep might not be found in a pill, a meditation app, or even in the brain itself, but in the ecosystem that lives inside your intestines. For most of the 20th century, if you wanted to understand sleep, you studied the brain. This made perfect sense. After all, sleep is a brain state. The EEG machines that measure brain waves during sleep became the gold standard. We mapped the electrical signatures of different sleep stages with the precision of cartographers charting new continents. We identified the brain regions responsible for initiating sleep, maintaining sleep, and waking us up. We built an entire scientific edifice on the assumption that sleep was fundamentally a neurological phenomenon, a conversation the brain was having with itself. But here's the thing about assumptions. They can be so obvious that nobody thinks to question them. Scientists call the connection between gut and brain the gut-brain axis, a network of nerves, hormones, and chemical messengers that allows your digestive system to communicate directly with your central nervous system. The main cable in this network is the vagus nerve running from your brainstem all the way down to your intestines. And traveling along this pathway are molecules that can either support restful sleep or undermine it. The relationship is bidirectional, a two-way street. When you sleep poorly, the bacterial community in your gut suffers. Scientists call this state of imbalance dysbiosis. And when that bacterial community is out of balance, it makes your sleep even worse. It's a vicious cycle that can trap people in chronic poor sleep for months or years, all while they're looking in the wrong place for solutions. This bidirectional relationship explains something that has puzzled clinicians for years: why sleep problems so often cluster with digestive issues. Patients with irritable bowel syndrome have higher rates of insomnia. People with inflammatory bowel disease report worse sleep quality. The gut and the brain aren't just connected, they're in constant conversation. And when that conversation goes wrong, both systems suffer. Sleep deprivation itself damages the gut. Studies show that even a few nights of poor sleep can shift the microbial population toward less favorable species, increase gut permeability, what some call leaky gut, and ramp up inflammation. The person who sleeps badly for a week doesn't just have a tired brain, they have a compromised gut that will make it harder to sleep well the following week. To understand how this relationship works, and more importantly, how it breaks down, scientists needed to study what happens when the system fails catastrophically. They found their answer in Parkinson's disease. If you've ever known someone with Parkinson's, you know the visible symptoms: the tremor, the stiffness, the shuffling gait. But what you might not know is that more than 70% of Parkinson's patients suffer from severe sleep disturbances. They have trouble falling asleep. They wake up constantly throughout the night. Many experience something called REM sleep behavior disorder, where they physically act out their dreams, sometimes injuring themselves or their partners. These aren't minor inconveniences. Poor sleep in Parkinson's patients actually accelerates the disease itself. It interferes with the brain's ability to clear out toxic proteins, including the alpha-synuclein that clumps together and damages neurons. It increases inflammation in neural tissue. It impairs the brain's natural repair mechanisms that operate primarily during deep sleep. Better sleep, in other words, isn't just about quality of life. It might actually slow the progression of the disease itself. Okay, admission time. I've probably eaten more protein bars in my life than I've blinked, and I'm always on the hunt for the very best. Then I found David Protein Bars. In fact, it was Dr. Peter Attia who clued me in. He was involved in their development. Knowing his standards, I trusted them immediately. Each bar delivers 28 grams of protein, just 150 calories, and 0 sugar. That's the best protein to calorie ratio I've seen, and the taste is legitimately good. Protein isn't just about muscle, it's essential for metabolic health and for keeping you full. And David's unique ratio makes these the most satiating bars out there. Here's the kicker. Demand has been so high that the full lineup of 8 flavors is currently sold out on the website. They'll probably be back in stock by the fall or autumn for us Brits. In the meantime, you can find them on Amazon or use the store locator on their website to grab them nearby. Try them out for yourself at davidprotein.com/mattwalker for a special deal for all you folks. Again, that's davidprotein.com/mattwalker. The problem, the standard Parkinson's medications, drugs that target the dopamine system, don't fix the sleep problems. In some cases, they make things worse. Doctors were stuck, patients were desperate, and that desperation led researchers to look somewhere unexpected. In a laboratory, scientists created mouse models of Parkinson's disease. These mice developed the characteristic brain changes of the condition, and sure enough, they also developed the characteristic sleep problems. Their sleep architecture, the normal pattern of cycling through different sleep stages, fell apart. They slept less during the day when they should have been resting. Their sleep was fragmented with constant transitions between wakefulness and sleep. Even when they did achieve deep sleep, the quality was diminished. The powerful delta waves that characterized truly restorative sleep were weakened like a radio signal fading in and out. Then the researchers did something clever. They didn't examine the brains of these mice, at least not first. Instead, they looked at their guts. They sequenced the bacterial populations. They measured the metabolites those bacteria were producing. What they found would change how we think about sleep. Your gut bacteria produce molecules called short-chain fatty acids. When they ferment the fiber you eat, you consume a carrot or a bowl of oatmeal, the indigestible parts reach your large intestine, and bacteria break them down into these useful compounds. Among these short-chain fatty acids, one stands out, butyrate. When researchers analyzed the guts of those Parkinson's mice with disrupted sleep, they found something important. Butyrate levels had collapsed. The bacteria that produced butyrate had declined, and with them, the production of this critical molecule. Here's where it gets interesting. When the scientists plotted butyrate levels against sleep measures, a clear pattern emerged. The more butyrate a mouse had, the more daytime sleep it achieved. It was a dose-response relationship. the kind of correlation that suggests causation might be at play. But correlation isn't causation. The scientists needed to prove that butyrate was actually driving the sleep improvements, not just tagging along for the ride. So they did the obvious experiment. They gave the Parkinson's mice supplemental butyrate. The results were clear. The abnormal sleep architecture began to normalize. The mice showed more stable sleep-wake patterns with fewer of those disruptive transitions between states. Their deep sleep improved. The delta wave power, that signature of truly restorative sleep, increased. And here's the crucial detail. This improvement had nothing to do with dopamine. The standard Parkinson's drugs, the ones that replace or mimic dopamine, had already failed to fix the sleep problems. Researchers tried both Madopar, a dopamine replacement therapy, and pramipexole, a dopamine receptor agonist. Neither worked. Butyrate succeeded where they had failed, operating through an entirely different pathway. But how does a molecule produced by bacteria in the gut affect sleep centers in the brain? The answer involves a protein called BDNF, brain-derived neurotrophic factor. BDNF helps neurons grow, strengthens the connections between them, and protects them from damage. Critically for our story, BDNF and its receptor, called TrkB, play a central role in orchestrating sleep. They're particularly important for building up the slow wave activity that characterizes deep, restorative sleep. When researchers examined what butyrate was actually doing in those mice, they found it was boosting BDNF levels across multiple brain regions: the striatum, the hypothalamus, the hippocampus. It was also activating the TrkB receptor, increasing the ratio of phosphorylated TrkB to total TrkB. The gut was sending a chemical signal up the vagus nerve and through the bloodstream. And that signal was telling the brain to prepare for sleep. To prove this wasn't coincidental, the researchers ran 2 more experiments. First, they gave the mice 7,8-DHF, a drug that activates TrkB directly, and the mice showed the same sleep improvements they'd seen with butyrate. The pathway worked. Then came the critical test. They gave the mice ANA12, a drug that blocks TrkB, and gave them butyrate at the same time. The butyrate stopped working almost completely. Without the TrkB pathway available, the gut's message couldn't get through. The causal chain was complete. Butyrate from the gut activates BDNF-TrkB signaling in the brain, and that signaling improves sleep. But butyrate wasn't just improving sleep directly, it was also reducing inflammation in the brain regions that regulate sleep: the thalamus, hypothalamus, and striatum. Parkinson's disease causes chronic neuroinflammation, a kind of slow-burning fire in neural tissue that damages cells over time. Butyrate helped dampen that inflammation, and it did so partly through the same BDNF-TrkB pathway. One molecule working through one pathway, producing multiple benefits: better sleep architecture, stronger neural connections, and reduced brain inflammation. A long-standing partner of today's podcast is Element, spelled LMNT. Element is a sugar-free electrolyte drink mix, and for me, it was the sugar-free part that made me start using it a while back. And again, I buy my own supply just to stay objective. Beyond having the electrolytes in the right balance, the other reason I'm a fan of Element is that it's scientific. If you look up the people who created the company, you'll find some pretty heavy-hitting physiology, biochemistry, and pharmacology knowledge baked into the product. And again, all of that comes without any sugar. Now, here's the update. Element's lemonade salt flavor, which used to be seasonal, was so popular that it's now permanent. You can get it year round. Happily, I badgered them and they have agreed to give you fine folks a free 8-count sample pack with any purchase of Element if you use the link drinklmnt.com/Matt Walker. So for free product with your purchase, just visit drinklmnt.com/Matt Walker. And as I said, you'll get some free product. The gut microbiome doesn't just influence whether you sleep well, it also influences when. Your body runs on a 24-hour clock. Actually, it runs on thousands of them. Clocks in your liver, your kidneys, your fat tissue, your intestines, all coordinating with the master clock in your brain. These peripheral clocks determine when your metabolism peaks, when your body temperature drops, when you feel alert, and when you feel drowsy. The gut microbiome, it turns out, oscillates too. The composition and activity of your bacterial population rises and falls across the day. And the short-chain fatty acids they produce, including our friend butyrate, correlate tightly with the expression of clock genes in tissues throughout your body. It's as if your bacteria are helping to wind the clocks, keeping them synchronized with the external world. In human studies, researchers gave participants butyrate supplements, 600 milligrams per day of sodium butyrate capsules for 12 weeks. When they measured clock gene expression in blood samples, they found significant increases in several key circadian genes, CRY1, CRY2, PER1, and BMAL1. These are the molecular gears that drive the circadian clock. The bacteria-produced molecules were talking directly to the machinery that controls timing throughout the body. The flip side is equally important. When your circadian rhythms are disrupted through shift work, jet lag, or irregular schedules, the disruption cascades down to your gut bacteria. The rhythmic production of butyrate loses its regularity. The chemical signals that should arrive at predictable times become chaotic, and that chaos feeds back into your sleep, making it harder to establish a consistent pattern. This has implications for the millions of shift workers and frequent travelers who struggle with sleep. Their problem isn't just in their brain's master clock, it's in their gut. The disrupted eating patterns, the irregular meal times, the processed foods consumed at odd hours, all of these affect the microbial population that's trying to help regulate their sleep. Addressing the gut may be just as important as addressing the light exposure and sleep timing that traditional circadian interventions focus on. If the gut microbiome holds this much power over sleep, the obvious question is, can we do something about it? Yes. And the interventions range from simple dietary changes to more aggressive medical procedures. The most straightforward approach is to feed the butyrate producing bacteria what they need. These bacteria ferment fiber, the indigestible parts of plants that reach your colon intact. Specific fibers, called prebiotics, are particularly good at promoting the growth of beneficial bacteria. One of these, beta-glucan, found in oats, barley, and certain mushrooms, was tested in those same Parkinson's mice. The results mirrored what the researchers had seen with direct butyrate supplementation. Butyrate levels rose, sleep architecture improved, and BDNF-TrkB signaling increased in the brain. In other words, you can achieve the same brain benefits by feeding your bacteria the right fuel. You don't need to take butyrate directly. You can let your gut bacteria manufacture it for you. This is why dietary fiber matters for sleep, even though fiber and sleep seem like they should have nothing to do with each other. The connection runs through the microbiome.
So for, it must be at least a decade now, I have been an avid, probably more like rabid consumer of protein shakes. But the hard thing, honestly, in the supplement space, if you really understand and do your diligence, is this critical thing called trust. It is very hard to find a brand that you can truly trust. That's when I came across the company Puri and the really impressive founder. Even though I'm sure it makes them less profit versus other quick and loose companies, Puri takes quality more seriously than any company I've ever seen before. They have so many offerings, gosh, protein powders galore, but lots of other additions. But that's what I was focusing on here. Why did I choose them? Well, it's really for 4 specific reasons. Number 1, they are free from hormones. Number 2, they are free from GMOs. Number 3, they are free of any pesticides. And number 4, and this is the critical confidence part, every single batch is third-party tested for over 200 harmful contaminants, things like heavy metals, etc. All you have to do if you are a neurotic nerd like me, you can even scan the QRI code on the back of the product to get the third-party independent laboratory test results. That's how much trust and confidence they place in their product. By the way, if you want a recommendation, go for the dark chocolate flavored protein powder. It's just exceptional. In fact, it's wonderfully addictive. I didn't just say that. Anyway, it delivers 21 grams of protein per serving. And for folks of my podcast right now, you can save 20%. So go over to puri.com/Matt Walker, and that is spelled PUORI.com, Matt Walker. So again, that is PUORI.com/Matt Walker, and you will get 20% off your product.
Then there are probiotics, live bacteria you can consume directly. A systematic review of randomized controlled trials found that probiotics and related supplements had a significant positive effect on sleep in adults. When researchers pooled data from studies of insomnia patients, they found that probiotics reduced scores on the Pittsburgh Sleep Quality Index by about 2 points. That might not sound like much, but it's considered clinically meaningful. The difference between poor sleep and acceptable sleep. Depression scores dropped as well by nearly 8 points on the Hamilton Depression Scale, which isn't surprising given the intimate connection between mood and sleep. Here's an important nuance though. Probiotics improved how people felt about their sleep more consistently than they improved objective sleep measurements. People reported sleeping better, feeling more rested, experiencing less daytime fatigue, but EEG recordings didn't always show dramatic changes. This might seem like a contradiction, but it's actually revealing. It suggests that probiotics may be affecting the subjective lived experience of rest in ways that standard sleep measurements don't fully capture. And for anyone who's ever spent a night technically asleep, but woken, feeling utterly unrested, that distinction matters enormously. The mechanisms seem to involve stress hormones and neurotransmitters. Certain probiotic strains like Bifidobacterium breve CCM1025 reduce cortisol levels. That stress hormone that keeps you wired and alert when you should be winding down. Others, particularly lactobacillus species, increase GABA, the brain's main inhibitory neurotransmitter. GABA helps quiet neural activity and promotes the kind of relaxation that precedes sleep. Still, other strains modulate inflammation, reducing the low-grade immune activation that can interfere with sleep quality. By modulating these systems from the gut, bacteria create conditions more favorable to sleep without ever directly touching a neuron. For severe cases, people with chronic insomnia that hasn't responded to other treatments, there's a more aggressive option, fecal microbiota transplantation, or FMT. You take the entire bacterial community from a healthy donor, process it, and transplant it into the recipient's gut. In small studies, FMT has shown promising results for chronic insomnia. Patients who received the transplant showed significant improvements in sleep quality, and their gut bacteria shifted toward a healthier composition, with increases in beneficial species like lactobacillus and bifidobacterium. The improvements correlated with the changes in microbial composition. The more the gut bacteria shifted toward a healthy profile, the better people slept. This remains an experimental approach for good reasons. Finding appropriate donors, screening for pathogens, standardizing the procedure, navigating regulations, these are significant hurdles. FMT isn't something you can do at home or buy over the counter, but the very fact that it works tells us something important about the relationship between gut and sleep. When you reset the microbial ecosystem, you reset something fundamental about how the body rests. So where does this leave us? We now know that sleep isn't just a brain state. It's connected to a vast community in your digestive tract, a community that evolved alongside us for millions of years, that has become intertwined with our biology in ways we're only beginning to understand. And that community is producing chemical messages that travel up to the brain, influencing everything from the depth of your sleep to the timing of your circadian rhythms to the inflammation in your neural tissue. The practical implications are significant. If you're struggling with sleep, the usual advice, consistent bedtimes, dark rooms, limited screen time, cool temperatures, remains important. These are the fundamentals, but they may not be sufficient. What you feed your bacteria matters. Whether you eat enough fiber, actual fiber from whole foods like vegetables, legumes, and whole grains, not supplements, matters. Fermented foods that contain beneficial bacteria may help. Avoiding unnecessary antibiotics, which can devastate the gut microbiome for months, matters. The overall health of your gut ecosystem, cultivated over weeks and months and years, matters. The research frontier is moving toward precision. Future treatments may involve analyzing your specific microbial signature, perhaps through a simple stool sample, and designing interventions tailored to your particular ecosystem. Prebiotics selected for your bacterial profile, probiotics chosen for their ability to fill gaps in your microbial community, perhaps even targeted metabolites delivered directly to compensate for what your bacteria aren't producing. We're not there yet. The large-scale clinical trials are still being conducted, the database is still being built, the optimal strains and dosages still being determined, but the direction is clear. The paradigm has shifted. Sleep is no longer just a brain state, a phenomenon that begins and ends between your ears. It's a collaboration between your neurons and the trillions of organisms that have made your gut their home. These creatures have been with us since before we were human. They shaped our evolution. They continue to shape our daily experience. And to understand why you sleep the way you do, to truly understand what happens when you close your eyes at night, you need to understand the life within. That's all for today. As always, sleep well, and I'll see you next time.